On page 87, we have 4 more of these volume problems. And it says to use 3.14 for pi. You may use the formulas on page 220 of the toolkit. I did not give you the toolkit, but we do have the formulas in our notes and also on the page before. Number 7. A candy company combines two, let me highlight the word combines, 2 identical square pyramids to make a box for its premium chocolates. The drawing shows the dimensions of the box. What is the volume to the nearest cubic inch? So I'll look at my dimensions and they are in inches. That's what we're looking for, so that's a good thing. So I need to do the volume of a pyramid. And remember, that's 1/3 times big B times H. So 1/3, big B, we got to work on. But the height of the pyramid, be careful here. The height of 2 pyramids is 8. So the height of 1 pyramid would be 4. So the height is actually 4 inches. Now the base of this pyramid is a square. So we've got a long side and a wide side that are equal. And here comes the math. 4/3 of 16 times 4. I said 4/3, I meant 1/3. So the volume is, type this in your calculator, 1 fraction 3 times 16 times 4. And that is 21 1/3 cubic inches. But that is not your answer. This is for 1 pyramid. But we have how many pyramids? We have 2. So 21 1/3 times 2. Do this on your calculator. It's all clear. 21 fraction 1 fraction 3 times 2 is 42 2/3 cubic inches. But it said to round to the nearest cubic inch. So would it be 42 or 43? So it might help to do this. Do 2 divided by 3 on your calculator to get that long line of 6s. So this would round to 43 cubic inches approximately. That is the total combined volume of these candy boxes. Those are pretty boxes. Number 8. At a sporting goods store, basketballs are sold in boxes. Each basketball has a radius of 11.9 centimeters. Every edge of the box measures 24 centimeters. When the basketball is in the box, how much space is left, that's a subtraction word, in the box, round to the nearest cubic centimeter. So I have a box that is 24 centimeters by 24 centimeters by 24 centimeters. It's a cube, basically. All of its edges are 24. And then I have a basketball in there that has a radius, so that's halfway, of 11.9 centimeters. So everything's in centimeters. That's good. So I want to find the volume of the box, which is edge to the 3rd power, or 24 to the 3rd power, or 24 times 24 times 24. And that is going to be a big old number. That's cubic centimeters. This is the box. So then let's find the volume of the ball, because it takes up space. It's not just in there flat. And that's a sphere. So we have the volume is 4/3. Radius to the third. I'm missing something. I'm missing pi. Let me check my formula. Anytime you have a circle, you gotta have pi. Sorry about that. I know better than that. Pi r to the third. So V equals 4/3 pi times 11.9 to the third power. Now you can type all that in your calculator. I like to go ahead and do this part just to show my work. So 11.9 times 11.9 times 11.9, it's ugly. It's 1685.159. And then I need to multiply that by pi and by 4 fraction 3. And that comes up to be about 7055.199.013. So we're going to have to do some rounding here. Actually, I'm going to go ahead and do my subtraction. I'm going to go ahead and round to the nearest cubic centimeter. So let's do this. So this volume is about 7,055 cubic centimeters. So I'll do 13,824. That's that one. Minus this one, 7,055. And so the space in that box that is not basketball is 6769 cubic centimeters. What a problem. If you can handle that one, I'd say you can do just about anything you want to do with volume. That one is pretty wicked. All right, we have 2 more to go that also look pretty wicked. On this one, we're building a model rocket, and it has the dimensions shown in the drawing. If the rocket has a diameter of 2 inches, what is the volume in cubic inches? Round to the nearest cubic inch. So they tell me that diameter is 2. So radius would be half that, or 1 inch. So I have a cone and a cylinder, and I'm going to do the cone over here. The volume of the cone, let me review my formula because I'm not doing too well with this. 1/3 pi r squared h. 1/3 pi r squared h. So I have 1/3 pi times the radius squared times the height, which is 6. So volume is 1/3 times pi times 1 times 6. So 1/3 times 3.14 times 1 times 6 is 6.28 cubic inches. And then here is the cylinder. Volume is pi r squared h. Pi, again, the radius is 1 inch. The height is 10. So we have pi times 10. And that's 31.4. cubic inches. We need to combine them. So we have 6.28 times 31 point, not times, plus 31.4. And that's 37.68 to the nearest cubic inch is going to be 38 cubic inches as the final answer. That one's pretty wicked. And finally, Max plans to build a storage shed with the dimensions shown in the drawing. What is the volume of the shed in cubit? That should be cubic feet. So the first thing I want to check is that everything is in feet. There are no inches or yards thrown in there, or meters. Everything is already in feet, so they were nice to us. So we need to do the roof. Let me just call it roof. That's going to be a pyramid. So volume is 1/3 times big B times height. So volume is 1/3. Let's leave a space for big B. We can go ahead and do 2. That's the height. So the base of this thing is sitting right here. This is where big B comes in. We got to find this area to use as big B. So I know that big B is 5 feet this way and 3 feet that way. So that's going to be 5 times 3. And so we're left with 1/3 of 15 times 2. You can do this mentally if you want to, or you can use your calculator. What is 1/3 of 15? 15 divided 3 ways is going to be 5. And 5 times 2 is 10 cubic feet. Now that's just the roof. We got it, or the attic. We've got to find the volume of the actual rectangular prism. And that one's going to be length times width times height. So we have 5 times 3 times 4. So we have 60 cubic feet. And then we have to put those together. 60 plus 10 is 70 cubic feet. That one wasn't quite as horrendous, but it's bad enough. Dealing with those fractions, 1/3, and those are not easy to do.